I'm looking here at the electrolysis of sodium chloride solution. It's connected up to a power pack. You can see perhaps here that the bulb is lit. So sodium chloride solution is a suitable electrolyte. I have here a plastic conical flask with the base cut off. I have a rubber bung through which I have two inert graphite electrodes. The left hand electrode over here is connected to the positive terminal, so the anode is on my left, and on my right then we have the cathode. Currently the sodium chloride solution is not very concentrated, so it is not effectively what we call brine. When we carry out the electrolysis of dilute sodium chloride, we get a different product at the anode. We get oxygen produced at the anode. In this instance, I don't want to look at the electrolysis of dilute sodium chloride. I want to look at the electrolysis of concentrated sodium chloride. And I have here some more solid sodium chloride. Currently there is no smell. If I was to go in here to see if there's any smell of bleach, I would not notice that typical bleachy smell of chlorine. But now as I begin to put in more salt, a lot more salt, to concentrate this solution, so we have a really good concentrated salt solution in there. Let's look at the processes taking place. Over here at the left-hand electrode, the anode, the positive electrode, we have negative ions attracted. And as I stand here speaking to you, I can already begin to smell chlorine, that bleachy smell. This should be carried out in a fume cupboard because chlorine is poisonous. At the left-hand electrode, what is happening is we have chloride ions and hydroxide ions attracted. Chloride ions from the sodium chloride salt, hydroxide ions from the dissociation of water molecules. H2O equals H plus OH minus. If the solution was dilute, we would have hydroxide ions discharged, and that would produce oxygen gas. However, in a concentrated salt solution, instead, we get chloride ions being discharged. So what's happening here in this instance with brine, concentrated sodium chloride, is we're getting chloride ions discharged, and the half equation is 2Cl minus equals Cl2 plus 2E minus. And we expect to see the build-up of a yellow-green gas at the top of this test tube here. That gas will have a bleachy smell. It will turn moist universal indicator paper from a yellow to an orange-red colour. It will subsequently make the paper go white because, as well as being an acidic gas, it is a bleach. Over here at the right-hand electrode, we have hydrogen ions attracted, hydrogen ions from the dissociation of water, and sodium ions attracted. Which will be discharged? The answer is the hydrogen ions. The hydrogen ions more readily accept electrons undergoing reduction than do sodium. So as a result, what happens here is that the hydrogen ions are discharged. The half equation is 2H plus 2E minus equals H2. So at this side we should see the build-up of a colourless gas, hydrogen, a gas that explodes with a pop when we introduce it to flame. I'm going to take a look at the test tube on the left. This is the chlorine gas. You can't exactly see the colour, but let's see if it will turn the damp indicator paper a colour that would indicate an acidic gas, which it does. You can see that it's beginning to make the paper go orange-red in colour. If I put that paper in there, the paper will eventually be bleached because chlorine dissolves in water to form two acids, hydrochloric acid and hypochlorous acid. Hypochlorous acid is a bleach. The bleach will kill germs, but it also removes colour. I think we can see the paper beginning to bleach there. Again, this should be done in a fume cupboard because chlorine is a poisonous gas. You see all the colours there you would expect. You can see at the top of the paper the yellow colour that we start out with. You can see the orange-red colour, typical of an acid, and you can also see the paper beginning to go white, the action of a bleach. This is evidence that the gas produced at the left-hand electrode, the anode, was indeed chlorine.